Hi, it's Dr. Z. In this video, I'll be introducing the concept of correlation. By the end of this video, you'll be able to graph a scatter diagram and understand three key features of a correlation. This video will require you to take handwritten notes. Please feel free to pause the video at any time to take notes. Well, what is a correlation? Let's break down correlation into its two parts. The prefix co refers to two things. The word relation refers to a relationship. Together, correlation refers to the relationship between two things. In the case of the definition, we will conduct a statistical technique to measure and describe the relationship between two variables. Now, what is extremely important is that these variables are typically observed as they normally exist. As you can see, this is so important, I've put it in bold and put a star there. In other words, the researcher cannot manipulate or change the variables. Using the ice cream sales and weather example from earlier, I, as a researcher, do not have the power or ability to change the weather, let alone manipulate all the ice cream sales in the city of Chandler. Now, personally, that kind of power would be nice, but I can't do that. Now, since this is a correlation, we will have two scores, an X score and a Y score. Now, let's discuss several key features of a correlation. First, we can illustrate correlations using a scatter diagram. It is also known as a scatter plot. Well, what does a scatter plot sound like? Basically, a graph with data points scattered around to show the relationship between the two variables. Since we have two variables, the X variable will go on the X-axis and the Y variable will go on the Y-axis. Let's use a real-life data set to show a scatter plot. This data set shows the responses of 5 students when I asked them how many hours they slept the night before class and how was their mood on a scale of 0 to 10 as they walked into my class. Please pause the video here to record the data in your notes. Now that you have the data set written down, do you see any potential relationships between hours slept and the student's mood? It may be difficult to see the relationship with just these numbers. So let's draw a scatter diagram to make it easier to see. First, let's draw the Y and the X axes, and we need to label them. Second, we need to label the graph with the corresponding variables. Hours slept goes on the X-axis, and mood goes on the Y-axis. Third, we need to number these axes. When you refer to the data set, one student reported sleeping 14 hours. God, wouldn't that be nice? So the X-axis will be labeled to 14. The Y-axis will be labeled to 7. Finally, we need to plot the first student's 2 data points. So the first student slept 2 hours and their mood was a 1. So we put a dot where those 2 points meet. We will repeat the same steps for the remaining 4 students and we will get a scatter plot. Now, looking at the scatter plot, do you see any potential relationships between hours slept and mood? Well, it appears that students who get more sleep are in a better mood. I kind of agree with that. In other words, as sleep increases, mood also increases. As seen in the previous scatter diagram, correlations can form patterns when the data is graphed. There are 3 patterns. First is linear. The root word in linear is line, so the data forms roughly a straight line. Our example of students' sleep and mood would be an example of a linear pattern or a linear relationship. The second pattern is curvilinear. What do you think is happening here? I think it kind of gives it away with the word curve in it. So the data forms roughly a curved line. The most common curvilinear pattern is the relationship between anxiety and performance. We also refer to this as the anxiety performance curve. So if you look at this, no anxiety or extreme anxiety results in poor performance. However, if you get just the right amount of anxiety, just the right amount of kick in the pants, you will have excellent performance. Now, the third pattern is technically no pattern at all, or in this case, no systematic relationship between variables. What do you think no correlation would look like? The example here shows that there is no relationship between income and shoe size. Thank goodness, because I have small feet. This scatter diagram reminds me of a chocolate chip cookie, or if you like something savory, a pepperoni pizza. So that's the type of pattern that I'm looking for when you want to confirm there's no relationship or zero correlation. Another key feature of a correlation is direction. In this case, direction refers to the way the variables change in relation to each other. There are two directions. First is a positive direction. The plus sign here does not refer to whether the relationship is good or better. Instead, positive means that the x and y variables change in the same direction. So what do I mean by the same direction? In other words, as x increases, y also increases. The opposite holds as well. So if x decreases, y also decreases. A real-life example here shows that there's a positive correlation between beer sales and temperature. In other words, beer sales increase as temperature increases. I guess people drink more beer when it gets hotter. What other real-life examples can you think of for a positive correlation? I'm thinking that since we live in Arizona, and during the summer, I can imagine that as temperature increases, so does our electric bill. Now, the second direction is a negative correlation. The negative sign does not refer to whether the relationship is bad or worse. Instead, negative means that the x and variables tend to go in opposite directions. In other words, as x increases, y decreases. We also refer to a negative correlation as an inverse relationship. The example here shows that there is a negative correlation between coffee sales and temperature. In other words, coffee sales decrease as the temperature increases. So I guess people don't buy as much hot coffee when it gets hotter? What other real-life examples can you think of for a negative correlation? My personal favorite from a student for a negative correlation was when he said, when you drink more alcohol, you have less cognitive functioning. So I guess as alcohol consumption increases, your ability to make decisions decreases. Now, the last key feature of a correlation is strength. I want you to think about it this way. If you are in a relationship with someone, don't you want to know if it's strong or not? Well, with correlation, we can actually measure and determine the strength of the relationship. When we do the math and calculate a correlation, the number value will range between a -1 to a +1. The -1 is referring to a negative correlation, and the +1 is referring to a positive correlation. Now, this range can be seen as a continuum, as shown here. The values of -1 and positive 1 are at the ends, and 0 is in the middle. What do you think happens at 0? I'm hoping you're thinking of a chocolate chip cookie or a pepperoni pizza. I hope you said nothing, or in this case, no correlation. Now, as you get closer to the extremes, what do you think happens to the correlation? Well, the correlation gets stronger as it gets closer to -1 or +1. In summary, correlation is a relationship between two variables that naturally exist in the environment. This relationship can be graphed using a scatter diagram or scatter plot. The relationship or correlation has also 3 key features: patterns, direction, and strength.